Okay, so we have a couple other labs to look at here. This one is 12L. And again, remember in class, the way I would want you to probably discover circumference is to take a bunch of circle shapes, right? Big circles, little circles, and so measure the little circle, measure the big, and the diameter, and then take the circumference divided by diameter to discover pi. So in class, I would have had you do 10 different shapes and kind of look at your answers and see what they were supposed to equal. This one is kind of another way a little bit to get at that. So again, read Lab 12L. This is on page, what? CA 252. And read it, pause, try to do it on your own, and then come back and we'll talk about it together. So go ahead and pause and try it on your own. All right. Hopefully you gave that a try. So let's look at the perimeter of the square here. So the square is 1 on every single side. So the perimeter of the square is 4 units. So there's 1, 2, 3, and 4. So obviously the circumference of the circle has to be less than 4. Now let's look at the hexagon that's in here. This is a distance of 1, so this is a half and a half, and these are equilateral triangles here. So we have a regular hexagon. So we know all the sides are half, but the only ones I really care about are the ones on the outside because of the perimeter. So there's a half, 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 and so forth. All right. So the perimeter of my hexagon is what, 3? Because I have 1 1/2, 1 1/2, so that's 3 units. So I know that the circumference of my circle is somewhere in between 3 and 4. And the question says, which of those two numbers does it seem to be closer to? Well, obviously the circle seems to be a little bit closer if you look at the picture. And again, mine isn't perfect. But it seems like it's going to be a lot closer to the hexagon versus there's a lot of space here. And again, space isn't for distance, but like this circle would have to touch out here for that to be part of its circumference. So there's it's much more sucked in, I guess, to the hexagon. So if you think of circumference as being, of this circle would be what? Pi d. Okay, and what's the diameter of this circle? It's 1. So pi times 1 is, again, about 3.1415, whatever. So it is much closer to 3. Another activity that I typically do with my trig students to get them to discover what a radian is, but you could kind of do this also in classes. If you had a circle and you had the diameter, I do it with the radius in trig because we're looking at radians. But you could have your students kind of measure how many diameters they think are going to go around that circle. So you could have them take a string and cut out the diameter and then kind of go around the outside and kind of mark it off and see, you know, how many diameters can go around there. And again, remember, circumference is pi times, or clowns get pied in the face, so I don't know why I'm writing that. Pi times d. Right? And so as far as you would expect there to be about 3.14159, right, diameters that would go around the circumference. So when they measure, and I'm not very good at drawing, but when you measure, you should be, you know, like, oh, there's 1 diameter, and then maybe 2 diameters, and then maybe 3 diameters, but I'm just a little bit short of that. And so getting that idea that there's pi diameters would go around your circle. All right, and again, getting to that idea of circumference is pi times d. All right, the next one I want you to look at is 12p. And I wish we could do this in class. And this is on page, what, CA 255? But you might want to read this. If you have string at home, you might want to try it on your own, or at least kind of think about how you would measure that. And we're going to go into 12S, which is on page CA 258. That kind of would play into that. So in class, if we were meeting face-to-face, we would do both of these to kind of get an idea of how perimeter and area are related. And this is an S. So go ahead and try 12S. It starts on the bottom there with number 1, and then it goes to the next page with number 2 and 3. So pause the video here and try those. Okay. All right, so hopefully you tried it. Again, listening to me helps, but it's much better if you try it on your own first. So it says if a rectangle has a perimeter of 12 units, okay, so we have 12 units, it says, then what could the area be? Draw 5 with, okay, so let's think about it. It could be, right, let's see, it could be, well, let's see, what do we want to try? If we have 10 and 10, that uses all of it. So let's try maybe 18 and 18. There would be what? 2, oops, not 18 and 18, sorry. How about 9 and 9? So if I have 9 and 9, that gives me 18, and then 1 on each end would give me a perimeter of 20, okay? If I make it even skinnier, right? Like if I cut it in half and kind of took that area and moved it down there, that would be what? Half would be there. And then what would I need? I'd have half over here, which would use up what? 1. I'd have 20 available. I've used up 1, which is 19. So half of 19 is what? 9.5? 9.5. And you kind of see it because these two make a 10. These two make a 10, which is 20. So do you see how these two make a 10? And those two make a 10. All right, and so what's the area of that? All right, so if I take 9.5 and either divide it by 2 or multiply by that, this one has an area of 4.75 square units. This one has, what, 9 square units? So I'll put those in the middle there. All right. Okay, what if we make it even skinnier? And I can't draw it to scale, but say this is a 1/4. Then if these two have to add up to 10, that's going to be what, 9.75? And again, you could use, like, if you don't, you could do 0.25 up here, 0.25 there. Again, so that would add up to 10, and the other two sides 10. So if I take 9.75 times, what I got, 0.25, okay, I have an area of, what's that, 2.4375. Okay, and that, again, that's only like, you know, a 1/4 of my unit. What could I do on the biggest side, okay, to get my maximum area? So remember in class we talked about how squares maximize area and they kind of minimize perimeter. So if you take 20 divided by 4, this would be what, 5 units, 5, 5, 5. And so that is the, you know, the most square shape I can get. And notice that area is 25 square units. And that's going to be the maximum area I absolutely can get, because remember, squares are your most, well, circles are going to be your most efficient shape, right? But next to circles, as far as if it has to be a polygon with straight sides, a square is going to be your most efficient shape. And so if we look at the chart on the next page, greatest area and smallest area, your area can get pretty tiny. If we go, and again, not that this is always physically possible, but again, pretend this is to scale. If this is 0.1, this is going to be what, 9.99? And 9.99, and then what, a 0.1 there. And again, these two add up to 10, oops, sorry, 0.01. 0.01. All right, so I have 9.99, so 99 hundredths, and that hundredth on there would make this 10, and there's 10. So those all add up to be 20. But then if I take base times height, so 9.99 times 0.01, all right, I have an area of, what is that, 0.099? Is there 3 nines there? Yeah. And that would be square units. So on that chart, if you think about it, I can almost get an area of 0 if I would line them up on top of each other. So if you think about, can you get an area of 0? Not if you have to have a rectangle, right? But if I could take my line of 10 units and basically line the other one right on top of it, right? 10 units. And there is 0 thickness on the sides, which I know that wouldn't make a rectangle. That would be my 20. So I can't quite get an area of 0, but I can almost, right? If these get really tiny, I can make it pretty darn close to 0. So that would kind of be like a limit in math. So I can get very low area, but what's the maximum area I can get? Okay, so my maximum is 25 square units. So when I'm stuck with a perimeter of 20, the maximum area I can get is 25 square units. Minimum can get pretty darn close to 0 when it's a super, super, super skinny flat thing. And so then if you go back to page CA 255, if you have a weird shape like that, if you have string and you can kind of go around it, you kind of know what your maximum area would be with that string. Because the perimeter, once you know the perimeter, by using the string to go around that odd-shaped lake, you could get your max, right? And then obviously your min is always really close to 0. So you could kind of think about how that would happen, where you could at least estimate your top end. And then, of course, you could always try to cover it, cut it into shapes and stuff to get the middle. All right, that's those two. And I guess if you look at page 12T, the next page, that kind of goes back to that. So this is an area of an irregular shape. So kind of you would use this knowledge in this lab to go ahead and answer the question on the next page, which is 12T. So they're kind of leading you to get to that assumption there. All right, I'm going to pause here. I'm hoping to do some of the other labs during class time, and we will go from there.